Okay, welcome to Unit 5, Hair Evidence. So now we're getting into particular types of physical evidence, and hair will be our first sample type that we're going to talk extensively about the sample itself, the collection methods, the limitations, the advantages of the particular sample, all the relevant features that we'll use to assess a particular type of evidence. So here we go with hair. Okay, so hair as a particular type of evidence is interesting because it's found all over the body. So we hopefully will have hairs from victim and suspect at the scene. There's variations in things like color, form, and structure of the hair, so we can examine that and determine key features of the hair. First of all, just because we find hair doesn't necessarily mean it's human hair, so we can distinguish between human and other animal hair, and that's actually quite easy to do. We can also, if it is human hair, narrow it down to the particular race, and then it becomes, of course, class characteristic evidence, which is not as valuable as individualized, but it's still something to go on. And then finally, if there is tissue attached, we can identify the individual through DNA analysis. So the limitation has been that you need that follicular tag. We'll talk about that shortly. But there's a new method that may allow for individualized DNA analysis even from hairs that lack the follicular tag, but that's still in the early stages and it's quite exciting, but we'll talk about that later on if it becomes more accepted. Let's focus now a bit about hair itself. So hair is mostly protein, so it's produced from a hair follicle. The protein in this case is keratin, which is a very strong protein, and that's what makes hair so long-lived. So we have hair samples that are hundreds of years old, even thousands of years old, because it's such a stable, keratinized example of a proteinaceous sample. So we have lots of different skin cells that are involved here. There's the melanocytes, which have melanin that can give rise to hair color. So in this case, we have the two different forms, the eumelanin, which is a brown to black pigment, but again, depending on amount, it could even cause hair to look blonde. There's the pheomelanin, which gives the red pigment that's characteristic of certain groups that will have that red hair from this red pigment, and so that's the particular form of melanin that gives rise to that one. All right, so moving on, let's consider the three major layers of hair. We have the cuticle, and this is what gives hair its strength. So we talked about hair being very strong from that keratinized protein, and so that's mainly in the cuticle that we'll find that keratin. The next layer in is the cortex, and this is which layer contains the pigment granules. So the natural hair color is based on the number and type of pigment granules that you have in your cortex. And finally, the medulla is the innermost portion, the core of the hair. And as we'll see, medullae can be fragmented or trace. They can be discontinuous, they can be continuous, and again, that will change for different animals. Even within humans, we tend to see the continuous medullae mostly among the Asian descent individuals, whereas you're much more likely to find fragmented medullae among individuals of Caucasian descent. So different features for different groups, but again, animal hair and human hair can be distinguished quite readily, and even within animals, you can distinguish between animals based on things like the cuticle pattern and the medulla type that you observe. All right, so a little more detail about the cuticle. As we already said, it gives the hair its strength because it's the outermost layer made of those keratinized proteins. As a result, it protects the cortex and even the medulla, which are much more delicate features buried deeper in the hair. And it has the appearance of shingles on a roof. So again, these cuticle patterns are not anything that you can solve necessarily with expensive shampoos, although the really cheap stuff can sometimes be harsh and cause split ends. But there's no reason to think that spending $50–$60 on a small bottle of shampoo is going to make it look any different. We're going to have the different patterns because that's just the pattern of the species. So if we look, there's the three different types. The imbricate, which is actually what human hair has as its cuticle pattern. There's coronal, which is rats and bats and cats, if that helps you to remember it. And then finally the spinous pattern, things like mink and animals, other animals like that would have a spinous pattern. So those are three different types, and again, it's just what the species evolved to have. So humans have imbricate, as do dogs and horses, and then we mentioned a couple animal types for the coronal and the spinous hair cuticle patterns. So as you see here now, we have, in addition to the drawing, we have an actual electron micrograph, scanning electron microscope image of animal hair, human hair in this case, actually, with the imbricate pattern. And again, it's a popular pattern, so humans, because we tend to focus on humans in a field like forensics, humans have this pattern, but so do dogs, deer, bears, hogs, goats, horses, so it's quite common in the animal kingdom. And again, it's it's nothing particularly special. It does look somewhat rough, and so that's why people can sell you $50–$60 bottles of shampoo, but it's not going to change that. So there we have again an example of a human hair under the scanning electron microscope, and it's a fairly normal hair pattern. So we'll talk in a little bit about how you can distinguish things like humans from dogs and deer and bears, since we all have that same cuticle pattern. Okay, so moving on to some other animals. So the cuticle patterns here tend to be rougher looking cuticles. The imbricate's a fairly fine cuticle pattern. So spinous patterns, we already talked about minks, seals, and rabbits also have this particular pattern, and it looks like spines. So that's how it gets its name of spinous, sort of like the tips of asparagus there with that spinous pattern. Coronal pattern, so the cats, the rats, and the bats, so rodents again, including mice and other things, but it's easier probably to have the rhyming rats, cats, and bats. And they look like crowns. They look like crowns nesting one on another, so that's what the coronal pattern would appear like. And again, it's fairly obvious and easy to distinguish between the different cuticle patterns, but no one cuticle pattern is individualized to a particular species. So we do have to still perform further tests to determine which animal type it is, and in particular with humans and other animals that have imbricate patterns, we'll mention one key feature that is quite obvious and makes it easy to distinguish human hair from other animal hair, even other animal hair with the imbricate cuticle pattern. Okay, so moving into the next layer, we have the cortex. So that's the layer beneath the cuticle, and it's made of cortical cells. So here we have granules of pigment that give the hair its natural color. So pigment will vary, both color and shade, even within an individual's hair, right? Especially those of us who are older, like myself, who have some white or gray hairs mixed in there. So there's far less pigment, if any, in those. There's the distribution of granules that can help to allow for comparison of two samples, or frustrate you with that, because as I just mentioned, even within an individual you have different amounts of pigment granules, or the absence of pigment granules altogether in truly white hairs. So you can have a random pattern, a peripheral pattern, even central or one-sided, so it gets complicated. We also have the possibility of ovoid bodies, which are large aggregations of pigment, and again, that can make for a difficult analysis, especially when an individual within their own hair can vary. So as we'll talk about later, we're going to collect a lot of hairs when we're doing comparison hair analysis, for that very reason, that you can have all of this distribution of these different patterns, in particular the cortex pigment, across the same individual in different hairs of that same person. So following up on that theme, we have some different distribution patterns. On the top left, we see a one-sided distribution pattern. So you can see that the pigment is really localized to the top of that sample as we look at it, and the underside has little, if any, pigment. Over to the right top, we have a peripheral, so it's all around the edges in a human hair. Then at the bottom left, we see a random pattern in an animal hair. And then finally at the bottom right, there's a central pattern in red human hair. So that red human hair we see again at the very edges of it. It doesn't appear to have much, if any, pigment, but more central to that hair shaft we see a concentration of pigment that, again, doesn't necessarily look red under the microscope here, but on the person's head we get that red appearance. So again, not a typical color, at least not a typical natural color, but a natural color that does occur in certain groups, and that can help to distinguish the ethnic lineage of an individual with red hair in particular. Now, from time to time, you'll find what we call ovoid bodies, which are just these egg-shaped bodies of intense pigment, and those are found in both animal and human hair. So humans and other animals will sometimes have these ovoid bodies. They're more prominent in animals like dogs and cattle than in people, but they do occur throughout the animal kingdom in most species, including humans, even though they're not as prominent in humans as those dogs and cattle are key examples of finding a large proportion of ovoid bodies in those hairs. Okay, now moving into the central canal there, the medulla. So this is a group of cells in the very middle of the cortex, the very central portion of the hair, right? So we consider it its own distinct layer, separate from the cortex. So the cuticle is the outermost, the cortex is the majority of the inside of the hair, but the very middle is the medulla here. At least for humans, it tends to be a relatively small amount. So we can classify medullae as different types. So amorphous, without a particular shape or pattern. There's humans and other animals too, but we tend to focus on humans, and we tend to be able to distinguish humans because the medulla is both amorphous and very, very thin. We'll talk about that medullary index. Continuous medullae we would expect for humans of Asian descent, African descent, and Caucasian hair tends not to be continuous for the medulla. It tends to be either fragmented or interrupted. So that's one way to distinguish those three major race types, is by the pattern of the medulla. When we talk about patterns, though, the other animals have some more intricate patterns than us. Again, humans would have amorphous patterns, as do some other animals, but you get some really interesting things with animals that have the uniserial or multiserial ladders. There's a lattice or a vacuolated pattern type. So we'll see some examples of these, but they're really, really neat. They just tend not to occur with humans, which tend to be our largest type of physical evidence. So we tend to focus on the humans with the amorphous pattern, but there are some other patterns out there. Finally, to make things even more difficult for hair analysis, sometimes the medulla is completely absent, and that makes it very tough to characterize the hair if you have an absent medulla. Alright, so here's a nice image of an amorphous medulla, probably human here based on how relatively thin that medulla is compared to the width of the overall hair. And we also see being continuous, at least continuous as long as we're looking at the shaft of this. So therefore it's probably a person of Asian descent. And finally, because of that doubling, do you notice how the mid-region we see a second medulla? It's also likely to be a facial hair. So just from this one image, we can tell that we're probably dealing with a person of Asian descent with a facial hair for this particular hair sample. Looking at this next hair sample, we see again an amorphous medulla, a relatively thin medulla comparing to the width of the overall hair, so probably again a human hair medulla pattern. And with this one being fragmented, it's either going to be European descent, Caucasian, or a person of recent African descent. And in this case, based on the pigmentation patterns, we're probably looking at a Caucasian hair here. So again, not without a doubt, the best way to analyze this hair, or any hair for that matter, is to have the follicular tag that we'll talk about. But based on that rough analysis, that's probably what we're looking at. And for our last amorphous medulla, this particular hair is what we would call interrupted. It's mostly there in terms of a medulla pattern, but you see there's some small gaps at the start and toward the end of the hair sample, at least this portion of that hair shaft. So again, we're probably dealing with what would likely be Caucasian hair, but without an analysis of the follicular tag, we couldn't be certain of the race of the individual, and certainly we can't know the sex of the individual if we don't have that follicular tag, or at least don't have some other information to help with that analysis. Okay, so moving on to pattern medulla. Again, we tend to focus on human hair in forensic science, but it's not to say that other animal hair is never important. So just because it's not human doesn't mean that we throw it out. But the more interesting patterns we tend to see less of the time, because it just tends not to be as relevant in the forensic setting. So here we see a nice uniserial ladder pattern from a cat. So we would expect the coronal pattern for the cuticle, but here we're really looking at the medulla, right? We can't get a good sense of the cuticle because it hasn't been stained in a way to make the cuticle really pop for us, but the medulla is very, very obvious, and this happens to be a uniserial, meaning a single ladder rung system for a cat hair. Another pattern that you might find for a medulla of another animal would be a multi-serial type ladder. So instead of a single rung system like we saw for that cat hair previously, here's a multi-serial, a many-runged system for a rabbit. And the biggest problem here is that this is a multi-serial pattern for a rabbit medulla, but rabbits can also exhibit the uniserial ladder that we just saw for the cat hair. So hair is very, very involved. It's a very difficult type of physical evidence to analyze because there's so much variation within a species, within an individual, even that makes it quite difficult. So be careful. We'll mention that unfortunately some hair experts have overstepped what is really allowable, at least in the past anyway. It was unfortunately far too common for hair experts testifying to the point that they were making it sound like they could individualize a hair they couldn't. Central Park 5, a historical case where hair analysis really helped to convict these 5 innocent young men, and they served significant prison terms before the jury verdict was overturned because of other evidence. But again, hair samples, you have to be careful. Hair is very complicated. Even today, it's still difficult to analyze it because of all these features that vary so much within a species and even within an individual hair. All right, so here's a nice lattice pattern. This is a deer hair, so you can see it's sort of like a garden lattice. It's a very nice and fairly ordered pattern, and it looks sort of like a lattice from a garden sort of lattice display. And so just another type of pattern medulla, and again, this one happens to be from a deer, but they're not the only species that exhibits the lattice, but it's not as common as some of the other pattern medulla types. Okay, and the last pattern type we're going to talk about for medulla is a vacuolated, and this happens to be a red fox hair. So this vacuolated medulla pattern is tricky in that it's very random, and so it's not as uniform as the other types that we've seen. It also appears in rats, and we said rats have that coronal cuticle pattern. Rats can have the uniserial ladder, the multiserial ladder, or even this vacuolated medulla pattern. So things get very, very tricky. across the animal kingdom. So humans tend to be actually one of the easier types to analyze, but some other animals can get really tricky in terms of the medulla pattern that they can have varies across them. At least humans, we tend to see everybody has an amorphous medulla pattern, but there's some differences with continuous versus non-continuous medullae. And for our final medulla picture, we have an absent medulla, so not much information we can gain from a hair like this that doesn't have really any medulla to speak of in it, and so that makes for relatively difficult analysis. Our only real hope with a hair like this is that we have that follicular tag, and then we could gain some nuclear DNA evidence. So but unfortunately it does happen that hairs at the scene may have absent medullas. Hairs collected from a suspect or a victim may have absent medullas, and that's just part of the trouble with hair, right? Hair is not as clear-cut as maybe the crime dramas might lead you to believe, and unfortunately even some of the hair experts that would testify to the ability to identify and individualize hair, in the past at least, that wasn't always the case, and there have been a number of cases that were overturned because of hair experts misleading juries in terms of how important that physical evidence was in those particular cases. So I think I've mentioned it a couple of times already, but let's just make sure that we all understand what's meant by medullary index. So the medullary index refers to the width of the medulla divided by the overall width of the diameter of that hair. And so for humans, the diameter of the medulla takes up about 1/3 of the shaft or less. Again, if we're dealing with a coarser hair, it will be a wider medulla, more fine hair, it'll be a smaller medulla, but that's why we're taking the index. We're dividing through to account for that people of especially Northern European descent are going to have very thin hairs, not a very wide diameter, whereas people of recent African descent are going to have much coarser hairs with wider diameters, but the medulla, the index of that medulla, the width of the medulla divided by the overall diameter of the hair, is going to be about 1/3 or less. Okay, for other animals it tends to be significantly greater, so noticeably greater, about half or greater of the hair. So that medullary index is much higher for the other animals, and that's what makes it pretty easy to distinguish between human and other animal hair as long as you have the medulla, right? We talked about the fact that the medulla is sometimes absent altogether, and that can certainly make for a more difficult analysis. All right, so now that we've got a decent understanding of the different layers of the hair and some other features to distinguish the different types of hairs, let's talk about the hair growth phases. So lots of money spent to cause hair to grow where it stopped growing and stop hair from growing where it's undesirable. So understanding these growth phases is important to people in those fields as well as people in the forensic science arena. So anagen is our initial stage, right? This is where hair is actively growing, and about 80 to 90% of scalp hairs in this anagen phase at any given time. So that's a good amount of hair. Again, I've mentioned the follicular tag a couple of times, and anagen phase hair is the most likely to give rise to a follicular tag if it's been forcibly removed. So that's good news for us. So we've got a decent likelihood of getting that follicular tag and being able to individualize the hair by nuclear DNA analysis of the follicular tag, but again, not all hairs in that initial active growth stage. Moving on to our transition stage there, catagen, we've got, again, the growth slowing down, so there's a relatively smaller percentage of hair in this, and it's not a very long stage, whereas anagen can last for years, catagen's a couple of weeks usually. And then finally, telogen is the dormant stage. The hair is no longer actively growing. It'll fall out on its own. Again, most of us lose around 50 or so hairs a day because it's in the telogen phase, and it's time for it to fall out. So those hairs are the least likely, the ones in telogen, to have the follicular tag still attached because they've reached the end of their life. They're no longer actively growing, and they're going to fall out naturally. And so those hairs are less valuable to us in terms of potentially great source of nuclear DNA, but unfortunately they're the most likely hairs to fall out because they've already sort of reached the end stage. So instead of the cartoonish image that we had on the previous slide, here's some actual hair images for the different phases. So we see that anagen phase. There's a nice bulb to that hair. It's actively growing. Catagen, we've still probably got enough nuclear DNA that we could do a DNA analysis and determine the individual who lost that hair. But by telogen there, we've really lost any hopes. It's very rounded. It's not much likelihood of having enough cellular matter there at the tip, the root end, I should say, to be able to analyze for nuclear DNA, at least not by traditional methods. So there we have it. The anagen and catagen phases, again, still a fair number of cells there at the follicle end, but not much in the telogen phase, and therefore the most likely hairs to fall out are the telogen, and they're the least likely ones to give rise to follicular tags. So we have to hope that we've gotten some anagen or catagen phase hairs if we're going to try the traditional methods for nuclear DNA analysis. Now, if the ones in telogen are the most likely hairs to fall out, what would the tips look like for hairs that have been forcibly removed one way or another? Well, if you have a rectangular end to the tip, then you're going to likely have hair that was cut by shears, right? So it will round again after a while, but if it's recently been cut by shears, it's going to have a rectangular end. If it's a tapered tip end, then it was probably cut by razors for that layered look. If it's been abraded, it's been worn away, that's the sort of appearance you'll have for that type of hair. Sometimes hairs just, snapped, broken, so you'll get that appearance if it's been snapped either by someone pulling it out by hand and not getting the full hair right down to the follicular tag, or if there was another object that was used to break the hair. Unfortunately, a lot of people will heat or chemically treat their hair, and so sometimes you'll get a burned or a singed end, particularly from flames or curling iron heat that gives that sort of appearance. Sometimes it can be even difficult to distinguish that tip end from really a follicle end. If it's been burned badly, you may mistake those. Split ends, we talked about earlier, not overspending on shampoo unless you choose to, but if you underspend on shampoo, sometimes the really cheap stuff will have harsh chemicals, and that can give rise to split ends, as can excessive brushing. So it's good to brush your hair, but not to overbrush it. And finally, as I mentioned before, the hair begins to round about 2 weeks after the last haircut. So if it was cut by shears or by razors, a couple weeks after that haircut, it's going to start to round off again, and it's not going to be so apparent how the hair was cut in its last haircut. Okay, and here we see some pictures of those different distal ends. So the tip ends there, if the hair was scissor cut, we see a nice sharp rectangular appearance. If it was razor cut, then again it appears to be more of a sharper cut. Burnt hair, as we see, can have some misleading features. It can look almost like it was the follicle end instead of a cut end. Or it can have even worse burning, as we see in that second burnt hair. If we go back up to the top, we've got the abraded hair that's been worn away at the end, rounded hair, so that's what the hair will look like a couple weeks after being either scissor cut or razor cut. And then finally, we mentioned if it's just pulled or broken, then you'll sometimes have an appearance like that bottom right image. So there we have it, the different types of distal ends you might expect to see in hair that's been cut or removed in one of these fashions. So earlier on we talked about how different hairs can be, the variations even within an individual's hair. So when you're collecting these hair samples, you're going to need to collect quite a few, right? 25 to 50 strands because of those variations. So within that set of 25 to 50, you're going to have some of it combed. The combed hairs are going to be those intelligent phase that are just going to fall out as they're combed, and you're going to have some that are pulled that are most likely in anagen or maybe catagen phase. You're going to package the comb and the hair separately, either in a folded paper like a druggist fold or in an envelope, or actually to be most safe, you should probably fold it in a druggist fold and then put in an envelope for safekeeping. So again, it's not going to be the most desirable thing for you or the suspect whose hair is being analyzed. We see our technician there collecting some hair samples from that suspect. Again, especially the pulled hairs, no one enjoys that, but hopefully the officers have done their work and you've got the right suspect, so the little bit of suffering they're doing is justice for whatever crime they've committed. We have a couple of different microscopic methods we can use to compare hair samples. So I've mentioned the scanning electron microscope before. That was that really nice high resolution image of the intricate pattern for human hair. The scanning electron microscopes work by sending an electron beam instead of a beam of visible light like we use for the traditional light microscope. So in order to have this method work, we need to have the hair plated with a metal, typically gold or gold palladium, could be a mix. And that's to make the hair conductive, or whatever sample that you're observing under the scanning electron microscope. If it's not naturally conductive, then we need to coat it in a conductor so that the electrons don't build up a charge there that either destroys the image or gives a false image. So by plating the hair with a very, very thin layer of gold, right? Gold's expensive. We're not going to use a ton of it, but a very thin layer of gold or gold palladium or some other either single or mixture of metals, and that allows the electrons to reveal the image, and you can get really, really high resolution down to very, very fine features with a technique like scanning electron microscopy. You can also use the light microscope, and in particular the comparison microscope, like we would use for comparison samples of bullet casings or fibers we'll talk about in the next unit. This will allow you to look at two different hairs, one in one eye and one in the other eye of these two compound light microscopes that have been joined together for comparison purposes. You can measure diameters, you can look at the key features of the hair, the medulla patterns, the pigment granules, and at least be able to identify if they were likely from the same source. Again, the only way to be certain would be to perform genetic analysis if you're lucky enough to have nuclear DNA material. But again, failing that, at least you can say if the hairs are consistent with one another. Looking at hair samples to try to gain some information about the ethnic group of the individual whose hair is being analyzed, we can take a look at some key features. There are some differences, right? We're one human family, but we do have our differences. And so if we're looking at head hair for someone from recent African descent, you're likely to see a flat to an oval cross section. There's going to be big pigment granules. They're going to be unevenly scattered. The medulla is likely to either be fragmented or absent in these individuals. So these are the key features. Again, it's not necessarily true that you're going to find all these things. You're also likely to find a coarser hair. We didn't even mention that. But again, things that you would be expecting if you're looking at a hair sample for someone of recent African descent. Now considering someone of recent Asian descent, the head hair for an Asian individual is likely to have a round cross-section. It's likely to have these large erratic pigment granules. And as we said, it's the human head hair type that's most likely to have a continuous medulla, and it will have the thickest cuticle of all the races. So as you remember, that cuticle is the keratinized outer shell, and so that's what gives the hair its strength. So you're going to expect the strongest, the most thermally and chemically resistant hair of all for people who are of Asian descent compared with the other ethnicities that we've discussed. And finally, for the groups that we'll discuss here, we have Caucasian or European head hair, and this one's going to have an oval to a round cross section. You're going to see more uniform pigment granules. The medulla, again, just like African descent hair, is more likely to be fragmented or absent, whereas the Asian head hair is most likely to give rise to that continuous medulla. So some key features, again, keeping everything constant. If we know we have human head hair and we see features that fall into one of these categories, then we're likely looking at an individual from one of those groups. If we have someone who's a mixed race individual, then they're going to have characteristics from those different races, and it's going to make things more complicated. So none of this is certain, but again, if you're seeing these features, then you're most likely to see that the individual you're looking for is from one particular ethnic group, not the other two that we've discussed. Now, we've mainly focused on head hair because that's what we tend to think about when we talk about hair, at least human hair. We tend to think about the hair on our head, but there are other regions, and the hair from those regions do tend to have their own characteristics. If we look at beard hair in particular, that tends to have a triangular cross-section. Really, we've talked about head hair having more of the circular or oval or flattened sort of cross-section, but with beard hair, we're looking at more of a triangular cross-section. We're also tending to find continuous medullae and maybe even double medullae, as we said earlier. Similar picture, if not the same picture, here on this slide showing that doubling of the medulla. So we see the top medulla is more continuous, and then the bottom medulla, at least here, is more of a fragmented or trace, depending on what the rest of the hair sample would look like. Now, if we consider hair from the extremities, so the arm hair or leg hair, hair from extremities is more likely to be short with a semicircular shape to it. It's going to be softer, generally speaking, and smaller in diameter. The tip ends are likely to be abraded, right, sort of worn away just because of the friction and things that tend to happen on those extremities. And you're likely to find the cortex pigment to be grain-like. So here we see an example of human arm hair, and you can see those different features that we just talked about pretty prevalently here in the micrograph. So again, not as common, but another type of hair that you're likely to find. We're mammals, we're covered with hair, and so this happens to be what arm hair would look like for a human under the microscope. And now we saved this one for last, pubic hair. Of course, it would be especially important in crime with a sexual component, where you would expect to find pubic hair samples. So in this case, we're going to have varying diameter across the length of the shaft. That's what gives rise to those kinkings or bucklings that you tend to expect to see in pubic hair. It has a flatter cross section. So that's what we see here in the bottom right. That image is, I don't know if anyone's seen the old Kevin Bacon Tremors movie. It sort of gives that appearance here. Almost looks alien, but that's a human pubic hair under the microscope. There's typically continuous medulla here. Again, as opposed to the head hair with Caucasians or people of recent African descent, we tend not to see the continuous medulla, but in pubic hair we do tend to see that across the races. And as I mentioned, it's kinked or buckled, and that's really as a result of that varying diameter. So there we have pubic hair, and again, if it's pubic hair that you found, then it's pubic hair that you'll need to collect for comparison's sake. So that same rule is in effect. The 25 to 50 hairs, half of them plucked, half of them forcibly removed. So, hopefully no one out there gets stuck with that job, but it's most likely to be the newest person on the force that gets to make those collections. If you've been paying attention throughout, you've been noticing that I've mentioned a few times that there are a lot of problems with hair. Hair's a great type of physical evidence. If you've got hair at the scene, or on the victim or on the suspect for that matter, that's not their own, then it's certainly worth investigating. But hair has its own host of problems, and so Here we see in these two images that even parts of the same hair can look different. So these are different portions of the same hair, and they have different appearance in terms of pigmentation, in terms of the medulla. So again, if we're talking about a hair of any size, 3, 4, or 5 inches long, you're going to have a lot of deviation along that hair sample, and that can give rise to a lot of problems. Now, if you're lucky enough to get one of those anagen or catagen phase hairs with the follicular tag intact, then you can do genetic analysis, and a lot of these problems won't necessarily cause you too much trouble. But without that, and if you're just looking to do comparison of hair, then it can get very complicated because of all of these differences, that multiple hairs from the same individual can have different appearance. Even the same hair can have a difference of appearance across the length of it. So it's a very difficult area. So if you're interested in hair and you want to be a hair analysis expert, you're going to have a lot of learning ahead of you to identify all of these problems. The last problem we'll discuss is the fact that a person doesn't have to stick with their natural hair color, right? They can dye or bleach their hair, and so that can make things even more difficult, right? Hair itself is difficult enough. Combine that with people's ability to change their hair at will, and you've made matters even worse. So hair tends to grow about 1 centimeter per month on average, so that's a little less than ½ inch a month. Again, that's an average. Some people have faster growing hair, and the hairstylists love those people because they're more frequent customers. Other people, the hair grows more slowly. So again, it's an average, but it's about what you'd expect for the average individual. Now, bleaching removes the color from the pigment granules. It's fairly harsh, just like heat treatment we talked about, singeing the hair. So it's not good for your hair to bleach it or to heat it with those hot irons and things like that, but people tend to want to do that sort of thing if they want to do it, right? We're humans and we have bizarre things where we never seem to like what we have. So people with curly hair want it straight, people with straight hair want it curly, and the chemical or thermal methods are one way to take the hair that you have and make it into the hair that you don't have to some degree. If the coloring's 1 centimeter from the root when the hair was collected, then that means 1 month has elapsed, right? If we're looking at an average of 1 centimeter per month growth, then 1 centimeter would mean that a month has passed. If it's another month later, then the coloring would be 2 centimeters from the root because another centimeter of new hair has grown. So that's typically how people who do dye their hair know that it's time for a touch-up, because those roots start to show the natural color, and once they get more than 1 centimeter or so, they become quite visible, and that's when people tend to go in for a touch-up. So there we go. Just because the hair's been dyed or bleached doesn't make things impossible, but it does complicate matters in an already complicated topic like hair. And finally, to end matters with our topic of hair, we'll talk specifically about follicular tags. I've thrown the term around, but it's probably nice to have the text up there for you to see it. So when a hair is forcibly removed, some of the tissue or blood vessels from the follicle might come with it. And that is the source of the nuclear DNA, right? Those cells that were removed along with the hair can be used for nuclear DNA analysis, and that should individualize it at least down to the level of identical twins or individual people if you don't have an identical twin. The problem that we've mentioned with this is that hair in the telogen phase can be removed without a follicular tag. So we said that most hair is in that anagen phase, 80 to 90%. So it's a good likelihood if our suspect was, in a violent altercation with the victim and the victim was able to pull some hair, then chances are we got a follicular tag as long as the suspect didn't clean it all up. But again, it's possible that if the hair was in telogen phase that we will not have the follicular tag and we will not be able to do the traditional nuclear DNA tests. So lots of developments happening in the field of hair. I mentioned that there's a scientist at University of California at Santa Cruz who's pioneered a method to get nuclear DNA out of hair without a follicular tag. But at least at the moment, it's a very expensive method. It's time consuming. It's only reserved for cases where it would be warranted. But in the future, perhaps we may see more widespread application of techniques like that. But at the moment, we're really mostly looking at follicular tags as our potential source of nuclear DNA. And if we don't have the follicular tag, you might be able to get mitochondrial DNA relatively cheaply, but that will just isolate down to a maternal line. It won't give an individual. So it would still be class characteristic evidence as opposed to individualized evidence. All right, we'll end it there. Hopefully you've enjoyed this foray into hair, and we'll see you next unit for our discussion of fibers. Take care, everybody.